Hi there. Today we're going to be looking at linear functions. So last lesson was just on functions by themselves. So now we're looking at linear ones, which means these are all going to form some sort of line. And the real difference between today's lesson and the last lesson is that today, when we look at a linear function, we're saying that we can represent it by an equation, which we've seen already, a table, which we've seen already, and then we can use those points in the table to create ordered pairs, and from those ordered pairs we can also create a graph. So there are four ways to represent a linear function. And so when you look here, for example, we can see already that we have something very similar last time, right? We have kind of the domain here, we have the range of values there, and we can see that we take those values, the x and the y, we turn them into a point, right? So ordered pairs here, x comma y, and we can take those same points and put them on a graph, which is what we did in our last lesson when we introduced it. We just didn't make that as part of the assignment, okay? So if I have a graph, if it says graph y equals x minus 2, I'm going to take that equation essentially, and it says to choose some values for x and then use the values to make a function table. You can see they chose 0, 1, 2, and 3. If you recall, I recommended using -1, 0, and 1. And then maybe a 2, so you always have something on the other side of the y-axis. I just prefer having a couple things on each side of the axis so I can kind of see how it goes through that point there. It's handy. And you can see they just started at 0, just fine, nothing wrong with that. So when you choose numbers on your own later on, you can decide how you want to do that, okay? So basically what they did is they said, let's take our x, let's plug it into our rule, right? This was our rule here, our equation's our rule, and see what the y value becomes. So when x was 0, you get -2, and you end up with an ordered pair. In doing this whole process, you end up with 4 ordered pairs that you can then plot on the coordinate grid, and you can then graph that function, right? So when you graph each ordered pair on the coordinate plane, and then draw the line, you've now graphed the linear function, and that's all that you're doing there. And so today we're doing the same thing. We're going to take an equation, we're going to use some points for x, going to plug them into our rule and find points for y, determine what the ordered pair is going to be, and then plot it on a graph. So it's just kind of a multi-step process here where you're doing, kind of working with the same equation multiple times in order to get a couple points that you can do this with. Again, when you're doing a graph, if it's a linear function, you really only need 2 points in order to draw a straight line. That's all you really need. But it's nice to have a few more to verify that you're doing things correctly. Let's take a look at a couple examples together. Alright, so we have y equals x plus 3, and they gave us some values of y, and it wants us to complete the function table. So we're going to plug -2 into our rule. So -2 plus 3. Well, -2 plus 3 becomes a +1. So our ordered pair is when x is -2, y is 1, and that's our point. If I want to plot it right away, I certainly could. I can go 1, 2 over the negative side and put a 1 right there. Right? This is -2, +1. The next one, x is 0, y is 3, so 0 plus 3 is 3, so our point becomes 0, 3. So when x is 0, y is 1, 2, 3. We also refer to that as what? That's our y intercept, right? That's our y intercept. Remember, y equals mx plus b, so that's our y intercept. So we have 2 points there, and again, like I said, I could draw my line right now and be good, right? Nothing wrong with that at all. I could do that. Do I need to do that right now? No, but I certainly could if I wanted to, and I can graph that. But because it has more values, I'll plug them in. So 1 plus 3 is 4. So my next value is 1, 4. We go 1, 1, 2, 3, 4. We can see it's right there. And then at 2, we have 2 plus 3 is 5. So 2, 5. And we have a point right there. We can look at our slope. We can see our slope is going up 1 over 1, up 1 over 1. So our slope is 1, which is true because in front of the x is just a 1. And everything looks good there. That's all you're really doing today, is you're completing a table and then graphing the function. With some of them, they're not going to give you a table, right? So we have the function here, and it says make a graph. So how you do that then is up to you. You decide which points you want to plot. A couple things you could do. Recognize here we have our y intercept. which means that when x is 0, y is going to be 2. So we already have 1 point right there based upon this being in the slope-intercept form. So we already have 1 point right there. So we have a point of 0, 2. I could do another point here. I could do it when x equals 1. And so when x equals 1, I could do 3 times 1 plus 2. 3 times 1 is 3, plus 2 is 5. So I have 1, 5 as another point. 1, 2, 3, 4, 5 as another point. At that point, I do have 2 points, and I could stop there. Like I said, like to always use a -1 as well. Help me put one on the other side. So this becomes -3 plus 2 becomes a -1. So when x is -1, y is also -1 right here. I can check my slope, which is 3 and 1. So I'm going up 1, 2, 3 over 1. 1, 2, 3 over 1. So that all looks good there. And I connect my dots. And now I have my graphed function like so. So it's good to have at least 3 points. I like to put them on both sides of the y-axis. I have a -1 and a +1, and I have the y-intercept there. Okay, just helps me out a little bit. For this next one, we have a -x there, so which means really, if I rewrite this, I have y equals -x plus 2, which means I have a negative slope of 1 over 1. I still have a y-intercept value here, a +2. When x is 0, I know that y is going to be here at 2. All right, now I can plug in a -1 if I wanted to. All right, so let's do a -1. I could do 2 minus a -1. Minus a minus becomes what? Add. So 2 plus 1 is 3. So when x is -1, y is going to be 1, 2, 3. Now when x is going to be equal to +1, we have 2 minus 1, which equals 1. We have 1 right there. We said our slope was -1, so we're going down 1 over 1, down 1 over 1. That all matches, looks great. We play connect the dots, and we are good like so, right? And that becomes my graph just like that. So that's the idea of what we're doing today. Okay, again, I like to use the values -1, 0, and 1 to use for my domain in order to find my range and help me graph. There's no right or wrong, but again, if you use larger numbers, you're going to run out of space in the graph. So that's kind of an easy way to do that, to use the y-intercept for 1 point and use -1 and 1. Keeps it really simple and pretty easy to do. Okay, so that's it today. You're going to do the same thing on a couple tables and a couple on just some graphing by themselves, and we'll come back and check them together in just a moment. See you in a second. Hi there, we're going to go over your homework for linear functions today. First of all, we had to complete the function table and then graph it. So let's do this here. We're going to plug -2 into the x value and add it to 4. So -2 plus 4 is a +2. So our point becomes -2, 2 for the first one. Plot that down over 2, up 2, and there we are there. The next one is -1 plus 4. So 4 minus 1 is 3. So our next point is -1, 3. So -1 and 1, 2, 3. We can see we're going up, which makes sense because our slope is a +1 over 1. We can also see our y-intercept is going to be at 4. So 1, 2, 3, 4. Our next point should be simply 4, right? So 0 plus 4 is indeed 4. And then when x is 1, y is going to be equal to 5. Like so. And then we draw our line, and we've now graphed it. Easy breezy. Next one. We'll do 2x minus 1 times -1. 1 times -1 is a -1. So we have minus a -1. Oops, sorry. What am I thinking? That goes in the wrong spot. Sorry about that. 2 times -1 minus 1. So we have a -2 minus 1 more becomes a -3. So we have minus, when x is -1, y is -3. And plot that down. So here's -1 and 1, 2, 3. Putting it right there. For 0, we have 0 minus 1, which is minus 1. We can already see that's our y-intercept value. So 0 comma minus 1 here. We can verify that's accurate by looking at our slope, right, our m value. We can see it's 2, which is 2 over 1. And we can see we went up 2 over 1. We're going to continue by going up 2 over 1. So we can anticipate our next point being 1 comma 1 is what our next point should be. So we have 2 times 1 minus 1. That's 2 minus 1, which is 1. And indeed our next point is 1 comma 1. And our last point is 2 times 2 minus 1, which is 4 minus 1, which is 3. So we have 2 comma 3. So 2 comma 1, 2, and 3, like so. We're going to connect our dots, make sure it all lines up, and draw our arrows. So that becomes our graph for the second one. All right, for the next part, let's graph its function. Okay, we said some of the simplest way to do it would be to say, let's plot our y-intercept first. So -6, we're going to go 1, 2, 3, 4, 5, 6. All right, so we're going to go down here, I guess, unless we go by 2. So you could count this by 2s if you chose to. Let's do that actually. Let's call these, we'll just plot it here. We'll just put it here as -6, all right? If I value for, if x is 1, then we do 1 minus 6, which becomes a -5. So we're going to go there. If x is -1, we have -1 minus 6, which is -7. So down even lower over here. So not a very pretty graph, but it looks something like that if you don't redo your points over there. Okay, next one. We have our y-intercept at -3, 1, 2, 3, so that's 1 point. We do -1. We have 2 times -1 minus 3. This becomes -2 minus 3 is -5. So 1, 2, 3, 4, 5 is there. And at 1, we have 2 times 1 minus 3. 2 minus 3 is -1. So we're going to be right there. And that becomes our graph for the next one. And finally, our last one here, we can see that our y-intercept value is going to be at 1. So let's do a -1 first. 1 minus a -1 becomes ++. So at -1, we're going to be at 2. 1, 2. And if we do a 1 minus regular 1, 1 minus 1 is 0. So at 1, we're going to be here, which makes sense because our slope is in front of the x. It's a -1 over 1. So we're going down 1 over 1, just like so. All right, the last one's a word problem there. I'm not going to worry about that one for you today. Hopefully you went through and did that there. An appliance repairman charges $60 for a service call plus an additional $40 per hour to repair the appliances. Okay, so essentially he charges $60 to come over plus $40 for every hour to repair the appliances. Write a function to represent this situation. So the function of x equals 60 plus 40x, where x stands for the number of hours you're going to be. That becomes your function table. Because it costs $60 no matter what, and then if it comes out for 0 hours, it still costs $60 to be there. 1 hour is 60 plus 40, 2 hours, and so on. Okay, so make a function table to find total costs. Okay, so for 1, we plug 1 in there, you end up with $100. For 2, you do 40 times 2 becomes 80 plus 60 is 80 plus 60, oh my goodness, 240, right? 80, 60, 140, oh my goodness, boy, tired. All right, and the next one here, we go 40 times 3 is 120 plus 60 is 180, and then we do 160 plus 60 is going to be equal to 220 for 4 hours. When you graph that there, so at $0 you're still starting at 60. When that's 0, you're still starting at 60, which looks like we're counting by 20s there, so I guess we would start here. It's not good to start a graph there at 60 and 0. That's a bad idea. You should regraph that, but whatever. At 1, we're going to be at 100. At 2, we're at 140. At 3, we're at 180. And 4, we're at 220. So that becomes my graph for how the appliance dealer charges your stuff. Okay? So that's it for today. Hope that helps you out, and we'll see you for next lesson in a little bit. Bye.